Notes for sections 2.8 and 2.7. We're kind of doing them out of order because 2.8 is completely review and 2.7 is mostly new. It asks us to graph f of x. F of x just a fancy way of saying y. Y is less than negative 3/4 x. So first thing we need to do is figure out where this line is. It is a line. Y equals negative 3/4 x would have a y-intercept of 0 and a slope of negative 3/4, down 3 over 4. Also going to go up 3, left 4. Because y is less than but not equal to that line, I don't want a solid line. Instead, I want a dashed line. So our line should be dashed. And then we need to figure out which way to shade. If the y is by itself, in this case it is, the easiest way to do it is to think through y is less than the line. I want to shade in the y values less than the line, which would be the ones down here. This only works if y is by itself. If y is not by itself, you can't do it that way. The other way you could do it is to pick a test point, any point that's not on the line. Usually 0, 0 is the easiest point to pick, but it's on the line this time. I'm going to pick 4, 0. So I'm plugging 4 in for x and 0 in for y. I get 0 is less than negative 3, which is false. And because it's false, I don't want to shade in the point I chose. I shade in the other side. So that is 2.8. 2.7 is on graphing absolute value functions. Graphing absolute value functions. This one asks us to graph y equals negative absolute value of 2x plus 4 plus 5. We are going to make a real big xy chart, plugging in a bunch of x values. So plug those in one at a time. I'll do the first one. I've got 2 times negative 5 is negative 10, plus 4 is negative 6. Absolute values is positive 6. So I have negative 6 plus 5. Plugging in negative 4 times 2 is negative 8, plus 4 is negative 4. Absolute values is 4. Negative 4 plus 5 is 1. Go ahead, pause the video. I want you to plug in the rest of them. Once you think you have them, you can push play, and the rest of them will appear in there. All right, so all of our values are shown there. We are going to plot our points. Negative 5, negative 1, negative 4, 1, negative 3, 3, negative 2, 5, negative 1, 3, 0, 1, 1, negative 1, 2, negative 3, 3, negative 5, 4, negative 7, 5, negative 9. And notice if I had plugged in like negative 6, that would have given me this point here. Kind of continue on with our pattern here. So the graph of an absolute value function gives us a v. That looks something like that. Notice the most important point we need is this point right here. Because if I had just plugged in negative 2, negative 1, 0, 1, 2, and that's it, I don't have a v. I would have a straight line if I only had those 5 points. So what we're going to do is we're always going to start by getting that point right there, the vertex, And then we're going to plug in a couple points on each side of the vertex. So the vertex is defined as the point where a function reaches a minimum or a maximum. It is the first point we're always going to need when we are graphing an absolute value equation. To get the vertex, we are going to take whatever's inside the absolute value, set it equal to 0, and solve. That is going to give you the x value of the vertex. So going back to that last example real quick, 2x plus 4 is inside the absolute values. So if I take 2x plus 4 equal and set it equal to 0 and solve, I get x equals -2. And -2 was the x value of my vertex. So that way we're not going to have to plug in 15 points and still not be sure if we've captured that vertex or not. We're always going to start by doing this and then set up your XY chart. -2 goes in the middle because that's my vertex, and then we're going to just plug in 2 points on each side and then plug in those. Example 2 asks us to graph y equals 2 times the absolute value of -1/3 x minus 2 minus 5. So anytime you're asked to graph an absolute value function, we should recognize that it's going to be a v. If I'm graphing a v, the first thing we need to find is the vertex. Take what's inside the absolute values, set it equal to 0. Times -3 on both sides. My vertex is at x equals -6. -6 is going to go in the middle of my XY chart. Usually I would plug in -5, -4, -7, and -8, but because I'm going to multiply them by -1/3 here, it's going to be easiest if we choose multiples of 3. Plugging in 0 gives me absolute value of -2. That's 2 times 2 is 4 minus 5. Plugging in -3 gives me 1 minus 2 is -1. Absolute value +1. 2 times 1 is 2 minus 5. And so on. 2 minus 2, that's 0 times 2 minus 5. Here I get 3 minus 2, that's 1, times 2 is 2 minus 5. 4 minus 2, 2 times 2, 4 minus 5. And apply points. And we get a nice looking V that looks like that. Go ahead, you try this one on your own. Pause the video, see if you can do it. I'll show you the solution here in a minute. So we're going to start by setting 2x minus 7 equal to 0 and solve. Whoops. Set up an XY chart. 7/2 goes in the middle. 7/2 is 3.5. We need 2 points on each side. Those would be the easiest numbers to plug in. Plug them in. 0, 6, 9, and plot your points. Anyway, that is the notes for sections 2.8 and 2.7. If you're having questions about things, please reach out. I'd be happy to help you out.